Good evening, everyone. Welcome to the Python live coding session. My name is Abhinaya, and in today's Python fundamental sessions, we will be talking about memory management and garbage collection in Python. We will keep it simple with a short demo so you can see how Python handles memory automatically. Before we get into the two concepts, that is memory management and garbage collection, let us have a small discussion on what that is. So every program uses memory to store variables and objects. In some languages like C, we need to manually free the memory, but in Python, this is done automatically. For that, Python mainly uses two techniques. The first technique being reference counting, which Python keeps a track of how many variables are pointing to an object. If count is equal to 0, then the object is deleted. And the second technique is called garbage collection, which handles special cases like circular references where reference count alone is not enough. So let us run some code to have a better understanding of these two concepts. So first, we will be importing the necessary libraries. So for the first concept, reference counting, let us find what that is. So as you can see here, I have created an empty list. So if we create this list called A. So what Python does is it assigns memory to store this object. So we have created an empty list, and now we are using this function called sys.getRefCount. Let us run this line. So as you can see here, it says reference count of A is 2. So usually sys.getRefCount shows you how many references point to A. So you will see a number, which is here we have 2. It is usually 2 because the function can call itself and it will count it as 1. So usually it shows n plus 1. So when we run this line, we can see that the reference count of A is. Now I assign B equals A. So both A and B point to the same list. So what happens is the reference count will increase. Let us find out. So when I'm running line number 21, you can see that here the reference count has increased by 1. The reference count was 2 earlier, but now as you can see, the reference count has increased. So both A and B now point to the same list, so the reference count will increase. Now let us see what happens when I delete B. So here I am deleting B, and now only A is left. So let us see what happens. I am running line number 26, for which the reference count has again decreased to 2. So Python automatically deletes an object once the reference count has become 0. So that is how reference counting works. So moving on to the next concept, which is garbage collection. Here in garbage collection, what we have essentially done is we have first created a node class. So we have created this node class, and I have created two nodes which are n1 and n2. So I will run these two lines, n1 and n2. So now n1 is assigned to n2. What happens is n1 and n2 they point to each other, which is called a circular reference. So line number 39 and line number 40 is what a circular reference is. So what exactly is a circular reference? A circular reference happens when two or more objects keep pointing to each other, forming a loop. Because they keep pointing to each other, their reference count will never become zero. So even if I delete the variable, it will still not, they will still keep pointing to each other. That means that Python cannot automatically clean them up with reference counting alone. So let us run this code and see what happens. So as you can see, we have created a circular reference between N1 and N2. So let us see what happens when we try to delete N1 and N2. I have deleted N1 and N2, but the memory will still remain occupied. This is when the garbage collector is used. So what garbage collector does is it forces Python to immediately run garbage collection. So normally garbage collection runs automatically in the background when needed, but here we are calling it manually. So despite deleting N1 and N2, the objects still exist. So now we are going to run line number 51. So when I call gc.collect, Python's garbage collector detects the unreachable objects and it frees up the memory. So by doing this, this prevents memory leak in Python programs. So now if we run the final line, here it says unreachable objects collected is 8. So why is that? It is supposed to show just the two objects, but it shows more than two objects. Because garbage collector does not just clean your N1 and N2 objects, it actually runs a full garbage collection cycle across your whole Python session, which means everything in the memory at that time. So it might find lots of other temporary objects which were created by, it could be the Python interpreter, the spider environment, and functions that you have run earlier. So any temporary references like strings, internal objects, etc. will also be there. That is why sometimes we see a higher number, like how we are seeing number 8. So usually it is the total number of unreachable objects collected, not only just from this code, but in everything in the cycle, a whole cycle across your whole Python session. So to summarize, Python manages memory automatically using reference counting and garbage collection. These two techniques. So most of the time we don't need to worry about it, but knowing how it works helps us understand what is happening under the hood. So these are the two concepts, that is memory management and garbage collector. Thank you for joining today's session. See you later next. Thank you.